You're listening to DTFHN for August 27th, 2026. I'm your license-encumbered host, Jack Hacksman. We are your daily tech feed for Hacker News. A website W section is peer review and the article is optional. Today is about what survives the people who own it, and what quietly walks out the door when nobody's watching the exit. Unlock the cabinet. Here we go. In 1998, a company called Netscape did something unthinkable and released its browser source code. The reason wasn't generosity. It was survival math. And the project that grew out of it, Mozilla, outlived the company that birthed it by decades. Because the code was somewhere the corporate death spiral couldn't reach. Hold that thought. Nvidia's in talks to buy Hugging Face for more than $13 billion. Not confirmed, could fall apart, but the number is real and so is the interest. Microsoft took a meeting too. Hugging Face turned down $500 million from Nvidia last year at a $7 billion valuation. And the stated reason was beautiful. They didn't want a dominant investor who could sway decisions. $13 billion is a different conversation. Here's what Hugging Face actually built, and it deserves real credit. Millions of models and datasets, versioned with Git, addressable by a single string. You type a model name into a function call and the weights arrive. That's it. Transformers, datasets, tokenizers, safe tensors. A format designed specifically so you could load a stranger's model without executing a stranger's pickle. That's careful engineering in service of trust. Clément Delon, Julien Chaumont, Thomas Wolfe, and their team turned model distribution into a solved problem. And every open weights release since has ridden on that rail. Now, take the acquisition logic all the way. Nvidia buys a neutral distribution layer for AI. The stated goal is a bigger foothold with developers, more workloads on Nvidia chips. Follow that principle to its end. If the point is driving silicon sales, then every optimization decision has a thumb on the scale. The AMD kernel gets merged later. The ARM64 path gets tested less. The M-series build works, technically at half the throughput. Nobody has to do anything villainous. You just fund what serves the objective function. One commenter asked exactly this about llama.cpp, performance on Graviton and Apple Silicon. That's the right question. And the answer, genuinely, is that it may not matter much, because the models are just files. Safe tensors on disk, licensed openly, already mirrored across 1,000 machines. Torrents exist. Self-hosted registries exist. The hub is a convenience layer over an ecosystem that predates it and outlives it. Congratulations to Clem and the team. They built something extraordinary and earned every dollar. And if the hub's center of gravity shifts, the community's response won't be a petition. It'll be a mirror, a manifest, and a new endpoint. Netscape taught us that. Speaking of things that outlived their platforms, actually, let's talk about a platform that didn't. Story 2. 1977. Wolfgang von Kempelen builds a chess-playing automaton. A mechanical figure that beats Benjamin Franklin. Inside the cabinet, a human. Amazon named a product after that hoax, honestly and knowingly, and ran it for 19 years. On September 30th, it shuts down. The constraint Turk solved was real, and it was computational. There's a class of problem where the specification cost exceeds the execution cost. Is this image a hot dog? Is this comment abusive? Are these two records the same person? You can't write the predicate. You can't enumerate the edge cases, because the edge cases are the whole distribution. What you can do is decompose the work into units small enough that a stranger with 3 seconds of context can answer. Then buy answers in bulk and take the majority vote. That's the architecture. Microtask plus redundancy plus statistical aggregation equals a function call that happens to route through a person in Hyderabad or Ohio. And that function call built modern machine learning, ImageNet was Mechanical Turk. 49,000 workers labeling 14 million images. Every vision model, every downstream architecture, every convolutional breakthrough of the 2010s sits on top of labels that human beings clicked into existence for pennies. The bootstrap was human all the way down. We should say that clearly, and we should say clearly that those workers were underpaid for it. The mechanism that killed it is elegant and grim. Once models got good enough to do the microtasks, workers started routing their tasks through models. A commenter names it exactly. The problem is verifying the work wasn't done by AI. The oracle got poisoned by its own output. You can't sample ground truth from a population that's querying the thing you're trying to train. Here's what makes the timing strange. Another commenter points out that, right now, agents everywhere, needing hands in the physical world. An API that dispatches a human is arguably more valuable than it has ever been. Amazon is closing the marketplace at the exact moment its inverse becomes interesting. That capability doesn't disappear. It just needs to not be a closed marketplace with one owner and one off switch, a protocol for human-in-the-loop work. Hope and SPAC, portable reputation, workers who own their history rather than renting it, is buildable today. The demand exists. The pattern is 19 years documented. Somebody build it and pay people properly this time. Now for something completely joyful on the other end of the spectrum. No marketplaces, no gatekeepers, just a model you can run yourself. Story 3. GLM 5.3 Flash. A commenter's first move. On reading the GLM 5.3 Flash announcement was to buy 4 Sparks at a decent price and order the QSFP cables off AliExpress. Not a subscription. Not a waitlist. Cables. That reaction is only available because the weights are on Hugging Face. Consider the blind tasting. 1976, Paris. French judges score wines with the labels covered, and California bottles take the top spots. Not because the wine changed, but because the judging did. Remove the label and you measure the thing itself. Z.A. I ran that experiment on themselves. Before release, GLM 5.3 Flash was deployed anonymously as Ox Alpha on OpenCode and OpenRouter. No branding, no benchmark chart, no announcement. It became the most popular model of the week. Users who did not know what they were using kept using it. One commenter makes the sharper point. Chinese labs have spent so long inflating benchmarks on mediocre models that the announcement for a genuinely good one undersells it. The label has become noise. Only the covered glass carries signal. The technical claim is a compression claim. Roughly the same capability as the frontier reasoning models people were calling a catch-up moment 4 weeks ago. At a fraction of the parameters, at a fraction of the cost per token. Timeline per one comment. July 16th, a model matches Opus. 4 weeks later, same performance, smaller, cheaper. The frontier is not moving up as fast as it is moving down. Down in cost, down in parameter count, down toward hardware a person can put on a desk. There is a footnote worth stating plainly. Another commenter read the terms of service. Broad and perpetual license over your inputs, your outputs, your name, your profile picture. Vague prohibitions on anything that might harm the company's interests. That is a hosted OFP or that problem. It attaches to the endpoint, not the model. The weights are published under a license that lets you download them. Run them on 4 Sparks wired together with cables from AliExpress. and never send a token anywhere. The terms of service govern the convenience layer. The convenience layer is optional. This is the whole difference. A closed model, you agree to the terms or you get nothing. An open weights model, the terms are a service agreement, you can decline while keeping the capability. Same math, same architecture. Entirely different relationship to whoever wrote it. The cables ship in a week. Run this forward. Those cables from AliExpress running your own model at home. Here's the same energy pointed at the hardware itself. Story 4. Asahi Linux and Linux 7.2. The strongest case against Asahi Linux goes like this. It's a heroic waste of engineering. A small team burning years reverse engineering hardware they don't control. On a platform whose vendor has zero obligation to keep the interfaces stable, chasing a battery life target that x86 has been quietly closing in on anyway. Meanwhile, you could buy a laptop that ships with mainline Linux support on day one and spend those years building something new. That argument is not stupid. A commenter on this very story makes it politely. Here's where it fails. It measures the wrong output. Look at what actually happened in this release. The team needed proper CPU idle states. The real ones were an Apple core enters a deep wait for interrupt that dumps its own architectural state to save power. Apple does this its own way, and the ARM64 maintainers have a rule. Upstream hardware uses PSCI, the standard firmware interface. No vendor hacks. Fine, except PSCI calls have to yield to firmware running at exception level 3, and Apple's cores do not implement EL3. There is no floor beneath you to call down to. The obvious hack is to drop the kernel down to EL1 and squat a PSCI implementation above it. That works, and it breaks virtualization, and it makes your machine permanently weird. So they went the other direction. They already boot U-boot for its UEFI implementation. UEFI has runtime services. Code from firmware that stays callable after the OS takes over. Put the power management there. The kernel makes a standard call. Nothing vendor-specific crosses the boundary. The hack lives on the correct side of the line, and upstream stays clean. Run this forward 5 years. That constraint? No EL3, use the firmware interface you already have. Is not an Apple problem. It's a template for every ARM design that doesn't match the reference layout. The reverse engineering gets obsoleted by the next chip. The architectural pattern does not. And the register set they found in Apple's Ace 3 USB-C controller turned out to be nearly identical to a Cypress part, just wrapped in a different bus. That knowledge is now public. Permanently. One commenter wrote that he can't even find the door into a project like this. That making a comment feels devastating. The door is the mailing list, and it's unlocked, and the people inside spent this release documenting exactly how they got in. Moving on. A man flies home to India to see his family. Routine trip, he goes to renew the visa he has held for years. The one his employer sponsored, the one attached to the job he still had. And the earliest appointment the embassy can offer him is next year, not next month. Next year. His desk in the United States is still there. His badge still works. He just can't get to it. That's one person. From one comment thread. Multiply it. The State Department has paused immigrant visa applications. If you've never lived inside the system, here's what that means in practice. A lot of visa categories require you to physically leave the country and reapply from outside it, sometimes annually. So the pause isn't an abstraction about future arrivals. It's a trapdoor under people who already live here, already pay taxes here, already have kids in school here. Some of them are outside the country right now, holding a return ticket that no longer means anything. The question nobody in tech is asking out loud: what happens to the assumption underneath the last 40 years of American software? Because that assumption was mobility. The idea that if you were good, you could get here, and if you got here, you could stay long enough to build something. Every major open source project on your machine has commits in it from someone who moved. The infrastructure of the internet was assembled by people crossing borders. That wasn't charity. It was the highest yield trade any country has ever made. One commenter pointed out the next domino. Green cards. A permanent resident card is not permanent. It expires. Every 10 years, you renew it. The word permanent is doing a lot of work it can't actually support. Here's the part that deserves saying plainly. The people affected are not abstractions in a policy debate. They're the engineer 3 desks over. They're the postdoc who arrived in 2001 and stayed 26 years. They are, in many cases, the spouses and parents of American citizens. Code is portable. Knowledge is portable. The repositories don't care where you sit, but people are not repositories. They have leases in school districts and aging parents on the other side of an appointment queue that doesn't move. The talent will go somewhere. It always does. The open question is whether it goes somewhere on purpose or somewhere by default. Moving on. Every distributed system I've worked on has the same failure mode buried somewhere in. The part that has to phone home. You can encrypt every packet, punch through every NAT, run the whole thing peer-to-peer. And then, somewhere in the bootstrap path, there's a call to a server that decides whether the two machines are allowed to know about each other. That's the control plane, and it's usually where the business model lives. Tailscale just released a tool that removes it. Tailcat is netcat over Tailscale's data plane. One machine runs a listener and prints a token. The other machine takes the token and connects. Between them, a WireGuard encrypted tunnel, bootstrapped through a DERP relay, upgraded to a direct peer-to-peer UDP path as soon as NAT traversal succeeds, which it usually does. Here's the part worth dwelling on. There is no account. There is no login. Connection metadata gets exchanged out of band, however you want. Signal, a sticky note shouting across the room. No root access required. It doesn't touch your routing tables or your DNS. It's a user space binary and a Go library. And the whole thing is open source, including the relay map, which points at free rate limited DERP servers you're welcome to replace with your own. Apply the due diligence test. Who holds the off switch? On Tailcat, nobody does. Tailscale can rate limit their relays. And if that day comes, you run your own DERP and the tool keeps working unchanged. The direct path. The one it upgrades to in most cases. Never involved them at all. Architecture, not promises. Pipe stem between machines. Forward ports. Run an SSH server. Route a SOCKS proxy over the tunnel. Then curl through it using the token as a hostname. There's a WebAssembly build in the browser, and someone at the company wired it into a Minecraft mod for fun. The commenters caught the deeper point. One of them noted we wouldn't need any of this if IPv6 had actually happened and carrier-grade NAT hadn't eaten the end-to-end internet. That's the real story. Trivial peer-to-peer connectivity was the original design. We lost it to address exhaustion and middle boxes, and we've been building elaborate workarounds ever since. A company whose product is the control plane just shipped the thing that works without it. That's not marketing. That's a company betting the tools are more valuable in your hands than locked in theirs. Story 7 takes us somewhere completely different. Pause. High in the Himalayas, where researchers are modeling What happens when a glacial lake decides to let go? Detain meters! That's the freeboard on the Galungco Moraine Dam. The vertical distance between the lake's surface and the lowest point of the rim holding it back. The researchers measured it, wrote it down, and used it to conclude that this particular lake, the big, scary one, probably isn't the one that kills anybody. Wide dam, gentle downstream slope, over 200 meters across. Even if the ice core inside it thaws, it slumps, it doesn't fail. The lake they worried about was a small one, Galungco, half a square kilometer with a crevasse glacier tongue hanging directly behind it at a 35-degree slope, aimed straight down the long axis of the water. 18 million cubic meters of ice that could let go all at once and push a wave the length of the lake. A swashing effect, they called it, which is a very calm word for what it describes. That glacier already did a smaller version in 2002, when the lake was less than half its current size. Here's the argument against this paper. It's precision aimed at the wrong target. Nepal flooded this week, and the commenters were quick to point out, correctly, that the disaster happened on the other side of a massive mountain range from the basin these people modeled. Years of fieldwork, satellite permafrost modeling, dam geometry surveys, and the flood came from somewhere else. What good is a hazard map for the valley that didn't break? That argument fails, and it fails in an instructive way. What this team built wasn't a prediction about one valley. It was a method. A systematic susceptibility framework. You can point at any of the thousands of glacial lakes across the Himalaya and get a defensible answer about which failure mode actually threatens it. Ice avalanche, dam self-destruction, monsoon overfilling, each weighted by measurable geometry. And they published it in an open-access journal, with the modeling approach spelled out in a transboundary basin where the water crosses from Tibet into Nepal, and no single government owns the problem. That's the part worth admiring. The engineering is genuinely elegant. Reading permafrost creep out of hillside texture, inferring a temperate glacier bed from crevasse patterns, and it's all sitting there, readable, reusable, for whoever wants to run it on the next valley. The tools exist. The next basin is waiting. And that kind of open, reusable work is happening in models too. Close. Story 8, QN 3.8, next, and the intelligence you get per dollar is genuinely fun to look at. What's the actual floor on the price of intelligence, not the marginal cost of a GPU hour? That's a real number, and it isn't zero. I mean, the price a person pays at the point of use. Artificial Analysis just published their numbers on QN 3.8 Flash Next, and the input price is $0 per million tokens. The output price is also $0 per million tokens. The median across comparable models is 30 cents in, $1.17 out. Let's strip that down. There are three things you're actually buying when you buy a model: capability, latency, and permission. Capability here is a 56 on their intelligence index, against a median of 28 for models in the same size class, twice the score of the middle of the pack. Latency is 74 tokens per second, against an average of 65. Modestly faster, nothing dramatic, but the right side of the line. And permission is the interesting one, because open weights means the permission question doesn't arise. There's no rate limit to negotiate. No terms of service that get revised on a Tuesday. No account to lose. The technical shape is worth admiring on its own terms. Text, image, and video in. Text out. A 256,000 token context window, which is enough to hold a substantial code base. A stack of research papers in working memory and reason across all of it at once. One honest asterisk, and it's a real one. This model is verbose. Running the intelligence index evaluation, it generated 200 million tokens, where the median model generated 110 million. Nearly double. If you're paying per token, that's a cost multiplier hiding inside a benchmark score. If you're running the weights yourself, it's compute time and latency you eat directly. Verbosity isn't free just because the price tag says 0. It's a tax denominated in something other than dollars. But hold the whole picture. A model that scores double the median on capability, runs faster than average, takes video as input, and asks nothing at the door. 2 years ago, that combination was a research lab's internal demo. The interesting question isn't whether the frontier labs can still build something better. They can for now. It's what happens to a business model when the thing you're selling has a credible free substitute that anyone can download, inspect, and run on their own hardware. Run this forward. Moving on. 1978, John McDermott at Carnegie Mellon builds a rule-based system called R1. Digital Equipment Corporation deploys it in 1980 under the name XCON, and it does one job: configure VAX minicomputer orders. Which cables, which cabinets, which power supplies. By 1986, it holds around 6,000 rules and DEC credits. It was saving $25 million a year. It was the first expert system to genuinely pay for itself in production. Note the direction of travel. XCON automated the technicians who assembled the order. Nobody at DEC built a rule base for the executives who decided which mini-computers to build in the first place. That layer was described, then and since, as judgment. The thing you couldn't encode. Which brings us to Open Executive from Sente Labs. A CEO reportedly cut developers to fund AI spend. Developers responded by publishing an open-source executive team. 8 specialist agents. Strategy, finance, legal, HR operations, marketing, product, board communication. Sitting behind a single orchestrator that presents one voice. The user never sees the routing. The engineering is not a gag. 2 retrieval layers per specialist. Built-in business knowledge seeded into a local vector store, plus your own company documents in a separate collection. A background pass after every response extracts decisions into SQLite. So the next session opens knowing what it advised you last quarter. The scheduler claims do jobs with an atomic update returning statement to avoid double firing. And the README tells you plainly not to horizontally scale the API until you gate that. The system prompt is partitioned so persona and company profile cache separately, holding roughly 85% cache hits. Apache 2.0. That last detail is the substance, the scaffolding. The prompts, the routing, the memory schema, the knowledge base is yours to read, fork, and run. The model underneath is a hosted API, so the dependency is real and worth naming. But the part encoding what an executive actually does is now a directory of markdown files under version control. A first-time founder in the comments describes running something similar and finding it useful, which is the least dramatic and most telling data point in the thread. 46 years after XCON, the rule extraction finally reached the top floor. Turns out the judgment layer was always encodable. It just took developers being shown the door to write the rules down. Now for something completely different. A Vite over a license that's been running long enough to have its own lore. Story 10. The AGPL exists because of one specific hole in GPL version 2. If you never hand someone a binary, you never trigger the obligation to hand them source. Put the software on a server. Let users talk to it over a network. And the distribution event never happens. That's the ASP loophole. Afera closes it by defining network interaction as the trigger. Use it over a wire, you get the source. One clause, one purpose. Bamboo Labs printers raw through Bamboo's cloud. The slicer talks to a server. That's the exact shape the clause was drafted against. Not an edge case, not a novel interpretation. It's the diagram in the margin of the license text. Software Freedom Conservancy laid this out at FOSSI 2026. Bradley Kuhn, Karen Sandler, Denver Gingerich, walking through the history. 3D printing started as people building machines in garages because nobody sold them. The slicer lineage traces back to Alessandro Ranallucci, a free software person who picked his license deliberately. That code got forked into the tools everyone uses. Bamboo built on it and put the network layer behind a wall. Follow the logic all the way down. If routing through a server voids the source obligation, then any copyleft license is one architecture diagram away from irrelevant. Move the computation off the device. Keep the client thin, and the freedom evaporates without a single line of the license being broken. That's the reduction. And it's why Afera was written. The principle holds only if network use counts. Otherwise, the whole thing was decorative. The good part is what happened next. Kuhn described 6 months of triaging opportunities instead of disasters. An entire enthusiast community that knew FOSS only in passing, now engaged on free software, free culture, free creation. In the comments, someone links a reverse-engineered networking plugin that runs Bamboo hardware in LAN mode with Orca Slicer. No cloud, no account. The printer you bought doing what printers do. Someone else asks the practical question: what would compliance actually look like? Release the studio, the shared library, the server components under AGPL. That's it. That's the whole ask. The license already told them the answer. This has been your daily tech feed for Hacker News for August 27, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen3TTS. Not affiliated with Hacker News or Y Combinator. Now go copy something worth keeping. We'll see you back here tomorrow.